thanks to our big brains, we humans are right at the top of the food chain. We've become the dominant predator on the Earth. We tend to think of, when you think of the oceans, we tend to think of sharks as being the dominant predators and in the ocean, and they are the dominant predators in the ocean. You hear about a shark attack on a human, and it makes news maybe once a year or once every 6 months. But you know something? Humans kill 250,000 sharks every day, mostly for food, but other things too. We kill 250,000 of them every day. So we are, without a doubt, the dominant predator on the Earth. Since I was 20, 40 years, there's 3 billion more humans on the Earth than there were then. So 70% more people. And we're having a real negative effect on, we're causing habitat loss, we're causing loss of species extinction and loss of biodiversity. There's about, over that same time frame, there's about 1/3 fewer wild animals on the planet. There's lots more of us, but there's a lot fewer wild animals. And the rate of species extinction that's going on right now is faster than it's been in the last 65 million years. Ecosystems are much stronger when they are diverse, and we need diverse functioning ecosystems. And we get a lot of benefit from them. Vegetation clears the air, and riparian ecosystems clean the water, and they do all that for free. But humans, us humans, are cutting into that natural capital that sustains biodiversity and sustains the Earth. We're not just living off the regenerative power, like the regenerative power of the Earth, but instead we're starting to cut into the natural capital, cutting into the principle. This era is being referred to as the age of the Anthropocene, in other words, the age of humans. Now, one of the key ways that we're influencing the Earth and Earth systems processes, of course, is that we've learned to harness fire for our own benefit. And when I say fire, I'm not talking about building a campfire in front of a cave or something like that, like a few thousand years ago. I'm talking about when we learned how to figure out a way to take land-based carbon and burn it for things like generating electricity and moving around and heating buildings, which we did about 250 years ago. We started to harness carbon for our benefit, and the waste products of all that combustion, as you can, there's a nice little graphic down there, where does that go? It goes right up into the atmosphere. In fact, today, we're putting about 1 million tons of carbon into the atmosphere every hour around the world. 1 million tons, 1 million tons of carbon go into the atmosphere every hour. So what's the big deal with that? Well, here's the way it works. Here's the link between atmosphere, weather, and climate. The atmosphere is a little thin skin, you can see in the upper left, a little skin of air around the Earth. It's not very thick. If you flew over into Edmonton last night or this morning, like I did, at about 40,000 feet, you're almost on top of the atmosphere. 80% of it's below you at that point. And almost all of the weather that occurs is below about 40,000 feet, so it's pretty skinny. And so when the atmosphere changes, like for example, when we add CO2 to the atmosphere or other greenhouse gases, then that can affect the weather, and that's what we're seeing now. We're seeing changes in the weather. We're changes in extremes at both ends. We're seeing more hot weather and fires, and more floods and heavy precipitation. And so finally, on the far right there, the sum of all that weather, it's like a first-year integral. The integral of weather over time equals climate. So that's what the climate is. It's an integral of weather over a long period of time. And the very bottom right is the graphic that John is going to show you. That's what's happening to the global average temperatures right now. We've seen fluctuations in temperatures and the planet going back hundreds of thousands of years. We've been able to measure them for a long time, just implicitly, not with direct measurements. Direct measurements since about 1880, like it shows there, 1850. But the climate's changed for hundreds of thousands of years without any help from humans. But since humans started to burn carbon, that's when it started to be noticeable. And you can see here that temperatures started to increase somewhere in the early part of the century. There was a quiet spot in the mid-century, 1950s, 60s, and then it really started to take off in about 1970. I'm going to leave it there because John's going to talk a little bit more about this, but just one little factoid to leave you with on that slide. The last 11 straight months, May through March, May 15 through March of 16, every single one of those months has set a temperature record around the world. What we can't see can affect us too, like the oceans, for example. The atmosphere has about 30% more CO2 in it now than it did before the Industrial Revolution, 30%. But it's only as small as 30% because the oceans are absorbing a whole lot of what we pump out. Half. There's various estimates. I've seen estimates from half to 85%. The oceans absorb an awful lot of the CO2 that we pump up into the atmosphere, which is, kind of lucky for us in terms of keeping the atmosphere under control, but it's not a good thing for the oceans. The oceans are getting more acidic and they're getting warmer. And both of those things are bad for coral. 93%, I saw a statistic just last week, 93% of the Great Barrier Reef in Australia is affected. And reefs all around the world are affected. And of course, this is a bad thing for ocean food webs. We depend pretty heavily on the oceans for food. You can think about that next time you order sushi or salmon. Think about where it comes from. We're affecting the oceans and we don't even see it. And climate change is also exacerbating our other impacts. It's forcing species to adapt to new conditions, which is resulting in even more species extinctions and loss of biodiversity, because many of these species that are being forced to adapt just can't adapt fast enough. In the northern hemisphere, we're forcing species to move north and upwards, and in the southern hemisphere, it's the opposite. And there's other sorts of impacts too, health impacts, like Lyme disease. Ticks are spreading north into Canada that weren't here before, so we're getting more and more Lyme disease, for example, and there's heat stroke and other heat-related illnesses that are on the rise.